I'm going to talk about horizontal and vertical asymptotes of some rational functions. So I'm going to make up, say, 4 over 3x minus 9 as my first rational function. So vertical asymptote is my first goal. I want to figure out what the vertical divider is in between this function. And we can find the vertical asymptote by taking the denominator and setting it equal to 0. So the denominator here, which is 3x minus 9, if I set that equal to 0 and solve it, my next step, I would add the 9 to both sides. So 3x plus 9, so equals 9. And then I could divide both sides by 3. So 9 divided by 3 is 3. And if I graph that, x equals 3, I'm going to dot it because it's an asymptote, and it should show that it is right in the position, that vertical asymptote, that the graph is curving towards, but never actually reaching right there in the center. It's found by setting the denominator equal to 0 because we're actually not allowed to plug 0 into this denominator, or not allowed to plug 3 into this function. So, for example, if I try plugging 3 into the function, it gives me undefined because 3 times 3 is 9, 9 minus 9 is 0. The value of 3 as an input makes 0 in the denominator. So that would be our vertical asymptote for this function, x equals 3. All right, so I'm going to just clean up some of my work right here to make it easier to see what's going on next. For the horizontal asymptote, I'm looking at what the y values tend towards for extremely large inputs. And it looks like they're tending down towards 0 here. So we're going to have 0 for our horizontal asymptote. So again, I'm just going to dot that. I'm going to keep them both orange. All right. So I'm going to take a look at another function and just looking again at its vertical and horizontal asymptotes. So let's say I make up the function -7 over 4x plus 9. Okay. Again, I just picked a function. I made it up, and I want to figure out what its vertical asymptote is going to be. Now I can see it's over here. Let's see. It doesn't look like it's -2 because I think I go through -2 here. It's certainly not -3. It looks like it's somewhere in between those two. So here it's harder to identify it. It's probably because it's not a whole number. So I'm definitely going to want to use that same technique of set the denominator equal to 0. So my denominator is 4x plus 9. If I set that equal to 0, I can subtract 9 from both sides. So 4x would be equal to -9. And then if I divide both sides by 4, my x is going to equal -9 divided by 4. So that's why this one was harder to see graphically, because it's not a whole number. It's -9/4 or 2.25, -2.25, right? Because it just wasn't a whole number. My graph, again, will get closer and closer, approach the x value of -2.25, but it won't actually go through it because it's not part of the domain. So there's a vertical asymptote at -9/4 or -2.25. All right, and then again for the horizontal on this one, the horizontal intercept, again, these are coming down towards 0 as a y value. So y equals 0, once again, is the horizontal asymptote for this one. Okay. One more, just another example. This time the asymptote is not going to be at 0 for the horizontal because we're going to pop a variable into the numerator here. So let's do an h of x function equals, how about 2x plus 3? I should make my fraction bar there. 2x plus 3 over, how about 5x plus 8? All right. Again, just picking some stuff here. Trying to find the vertical and then the horizontal asymptote. All right, for my vertical, again, it's just about the denominator. The numerator has nothing to do with the vertical asymptote. I just need to figure out where the bottom would be equal to 0. Okay, so if my bottom is 5x plus 8, I can subtract 8 from both sides. So this would give me oops, I want to keep that in a note. This would give me 5x, 0 minus 8 is negative 8. And divide both sides by 5. That would give me x equals negative 8 divided by 5. So x equals negative 8 fifths is going to be our vertical asymptote here. Okay, so denominator equals 0. What did I just do? I don't know. Just click on something, an accident there. Denominator equals 0 is the way of determining where the vertical asymptote is going to be. All right, horizontal asymptote. So previously we were able to drag up and just kind of see that this was getting closer to 0 for y. Not the case in this one. So if I go up, it's like 3.8, 3.9. It's kind of getting closer to 0.4 maybe. And if I drag down, 4.1, 4.0, I'm going to guess it's 0.4. So visually, I can get a sense for guessing that it's 0.4. Let me color code it real quick, and then we can talk about analytically verifying that. Looks like 0.4 is going to be right there in the middle for the asymptote for the horizontal asymptote. Now we can also verify that algebraically with a ratio of leading coefficients. I have 2x over 5x, and 2 over 5 is, of course, 0.4. So that would be another way of expressing this. 0.4 or 2 fifths, same thing. And it's that ratio of leading coefficients. The quantity of x in both of the parts of the fraction, 2 divided by 5, is 0.4. So that is really the horizontal asymptote. Okay. So asymptotes, whether they're like the vertical, can be found no matter what, just by taking my denominator, setting equal to 0 and solving for x. You can even do that if you don't have numbers in those positions. You can just solve for x in terms of the variables. Doesn't matter what's in the bottom, but take this bottom, solve, get x by itself to find the vertical asymptote. Horizontal, again, I can think about this algebraically. The horizontal back up on this one. Let me turn these guys off real quick. Again, it is a matter of ratio of leading coefficients. And see how there is 0x in the top to go with these 3x in the bottom. So 0 divided by 3 is 3. And again, I can see that my graph is going down towards 0 as an output. So y equals 0 confirmed there.